Welcome to the Al Jazari channel, where you will learn how to apply the economic production model to solve real-life problems. The EPQ model is not only used to calculate the economic production quantity, but also used for many other parameters such as the runtime, the cycle length, and much more. Learning how to compute these parameters has not been easier, as you will find in this video. So, watch this video to the end to enhance your skills. The problem solved here is from the Operations Management book written by William Stevenson. It illustrates the use of the economic production quantity model in production planning. A company that produces hair dryers buys some of the components, but it makes the heating element, which it can produce at the rate of 800 per day. Hair dryers are assembled daily, 250 days a year, at a rate of 300 per day. Because of the disparity between the production and usage rates, the heating elements are periodically produced in batches of 2,000 units. Solve the following questions. Approximately how many batches of heating elements are produced annually? If production on a batch begins when there is no inventory of heating elements on hand, how much inventory will be on hand 2 days later? What is the average inventory of elements, assuming each production cycle begins when there are none on hand? The same equipment that is used to make the heating elements could also be used to make a component for another of the firm's products. That job would require 4 days, including setup. Setup time for making a batch of the heating elements is a half day. Is there enough time to do this job between the production of batches of heating elements? Explain. As usual, let us start with the given. The production rate, P equals 800 units per day, whereas the usage rate, U equals 300 units per day. The number of working days per year is 250 days. The production is done in batches of 2,000 units each. This means that Q equals 2,000 units. Starting with the first question, approximately how many batches of heating elements are produced annually? The number of batches of the heating element produced annually can be determined by dividing the annual demand D by the batch size Q. Since the daily demand or usage and the number of working days per year are known, the annual demand can be calculated by multiplying these two values. This is because one of the assumptions of this model is that the demand is spread evenly throughout the year. So, D equals 300 multiplied by 250 equals 75,000 units per year. Well, divide this 75,000 by 2,000. This results in 37.5 batches per year. The second question is, if production on a batch begins when there is no inventory of heating elements on hand, how much inventory will be on hand 2 days later? Since the production on a batch begins when there is no inventory of heating elements on hand, the amount of inventory after 2 days of production is the difference between the number of units produced in 2 days and the number of units used in 2 days. The number of units produced in 2 days equals 2 days multiplied by the production rate. P equals 2 multiplied by 800 is equal to 1,600 units. While the number of units used in 2 days equals 2 days multiplied by the usage rate, U equals 2 multiplied by 300 is equal to 600 units. Consequently, the amount of inventory after 2 days of production equals 1,600 minus 600 is equal to 1,000 units. The third question is, what is the average inventory of elements, assuming each production cycle begins when there are none on hand? To find the average inventory, we have to find the maximum inventory and then divide it by 2. Whereas, the maximum inventory equals Q multiplied by between brackets P minus U and divided by P. Substituted by Q equals 2,000, P equals 800, and U equals 300. So, the maximum inventory equals 1,250 units. Divide 1,250 by 2 results in an average inventory of 625 units. Then the average inventory is 625 units, assuming each production cycle begins when there are none on hand. The last question is, the same equipment that is used to make the heating elements could also be used to make a component for another of the firm's products. That job would require 4 days, including setup. Setup time for making a batch of the heating elements is a half day. Is there enough time to do this job between the production of batches of heating elements? Explain. To answer this question, we have to answer another question, which is, how much time is available to run the other job? The other job must be finished during the pure consumption time for the heating element, which is illustrated in this figure. The end of the pure consumption time is when the inventory of the component for the heating element falls to 0 units. If the other job takes longer than the pure consumption time, we will run out of inventory of the heating element. To learn more about this figure, click the above link. As illustrated in this figure, the cycle time includes both the runtime and the pure consumption time. Consequently, to find the pure consumption time, the cycle time must be obtained first. The cycle time or the cycle length can be calculated by dividing the batch size, Q, by the usage rate, U. So, the cycle time equals 2000 divided by 300 equals 6.67 days. As stated before, this is the time between starting production runs of the heating element. Well, the cycle length equals the runtime plus the pure consumption time, whereas the runtime equals the time for production of the batch size plus the setup time. And the time for the production of batch size equals the batch size Q divided by the production rate P equals 2000 divided by 800 is equal to 2.5 days. So, the runtime equals 2.5 plus 0.5 equals 3 days. Using the values of the cycle time and the runtime to find the pure consumption time. 6.67 equals 3 plus the pure consumption time. This results in the pure consumption time equals 6.67 minus 3 is equal to 3.67 days. Then, in conclusion, there will not be enough time to run the other job because the other job requires 4 days while the available time is only 3.67 days. In this video, one problem is solved to illustrate the use of the economic production quantity model in production planning. If you need more details or more solved problem, do not hesitate to contact me. If this video is helpful, press like and comment. To watch more videos related to inventory management, click the above link. And keep following us. If you did not do yet, subscribe to the Al Jazari channel and activate the alarm to be notified of the new videos. Goodbye.